Transformations of graphs is a method of graphing which is supposed to be almost instant. By almost instant, I mean not quite as fast as this. You really should know y equals x squared. You should know that it looks like a bucket, and crucially, you should know that it goes through certain key points. It goes through 0, 0, goes through 1, 1, and it goes through 2, 4, goes through negative 1, 1, and negative 2, 4. So that's a famous graph that you should be able to lay down instantly. I'll give you just another two examples you should lay down instantly. Y equals x cubed, you should know that that's a snake. Crucially, it goes through 3 key points, and on its journey through the middle of those, it looks flat. By flat, I mean that if you put a ball there, or imagined a ball there, it would not roll down the hill. And that goes through 1, 1, 0, 0, and negative 1, negative 1. Just one final example is y equals root x. That goes through 0, 0, 1, 1, and 4, 2. And it does not go in both directions, it just suddenly leaps out from 0, 0. So that's what I mean by instant graphing. Those are graphs that you should be able to draw more or less instantly. Now, so what I mean by semi-instant graphing, I mean if instead of drawing that you had to draw this, or instead of drawing that you had to draw this, or instead of drawing that you had to draw this. Well, I regard that as just a tiny change. Now when it's as tiny a change as the subtraction of 1 or the multiplication of 2 or the putting of a negative out the front, I think that the best method will be to draw this and then transform it somehow, adjust it somehow. And that's what this topic is. It says that if there's a tiny change between the algebra that would have led to an instant graph and the algebra in what you have to do as a graph the instant one and then adjust it. Now how do you do that? Well, here's the method. It's a 4-step method. Step 1 is lay down the basic graph, which I've now done for these 3. Step 2 is to do a multiple choice decision out of 5 possible types of transformations. And here they are. 1 is movements towards positives. So for example, a 9 becoming a 10 or a 5 becoming a 6. In other words, moving the graph that way or moving the graph that way. Second type is movement towards negatives. In other words, moving the graph to the left or moving the graph down. Third is a stretch. So for example, if you stretch the graph out, or the graph out like that, or graph out like that. The fourth is a contraction. In other words, you squish the graph. So for example, if you squish that in there, or you took this and squished it down like you were flattening it. And the fifth is a flip, which is the informal term for a reflection. By that I mean if this graph suddenly went there, or this graph suddenly went there. That's what a flip is. Now my claim to students is that just by looking at the mechanics of the adjustment, like the little thing that made it a semi-instant graph rather than instant graph, you should be able to have a gut feeling about which of those it is. Now it is just supposed to be a gut feeling. It's important that it's a gut feeling rather than anything that you think through too carefully. But when I see a -1, I think movement towards negatives. So that's my gut feeling about that. When I see timesing by 2, I think a 1 becoming a 2, or 3 becoming a 6, a 0 staying as a 0, I think stretch. And when I see a negative, I think a 4 becoming a -4, or a 2 becoming a -2. That makes me think that things are going to get flipped from the other side, from one side of an axis to the other. So that's my gut feeling. That's step 2, is to make that decision about your gut feeling. Step 3 and step 4 are done in the same breath using a decision procedure, and that decision procedure is before or after. Okay? Now, this decision procedure involves imagining that your favourite number was where x was. So if my favourite number was 10, the question is this. Would I subtract the 1 before I squared or after? In other words, this little thing, this little complication that makes it a semi-instant graph rather than an instant graph, I'd do that before the application of the main function that determined the shape or after. Now, basic rules of operations from primary school will tell me that this is an after one. I would definitely do the squaring first and then I would subtract 1, whereas this one is a before one because the brackets indicate that I need to cube all of this product, not just what is physically nearest to 3. So if I had my favourite number of 10 there, I would go 2 times 10 and then I would go cubing. Then I would go 20 times 20 times 20. Whereas here I would go 10 times 10, getting 100, and then I'd subtract 1. So that's why the subtraction of 1 is after there, whereas the doubling is before there. Finally, if my favourite number, let's say, was 9 now, because it's easy to square root, I'm pretty sure that I would square root 9 and get a 3 and then stick a negative on. I definitely wouldn't stick a negative on the 9 because then I wouldn't even be able to square root it. So that's an after one. Now here's the thing. The before ones are illogical and horizontal. In other words, they're the opposite of what I told you, whereas the after ones are logical and vertical. So in other words, the after ones, these two, are exactly what my gut told me. That's what the L for logical means. And they're vertical. In other words, up rather than to the right, or squishing vertically rather than horizontally, or flipping across the x-axis rather than the y-axis. So I'll just explain how these go. So my gut feeling was that there was a movement towards negatives because it's an after one, that's logical and vertical. It was a movement towards negatives in my gut, and that's what it's going to be because it's logical. And it's a vertical movement towards negatives. So that fat dot becomes this cross. This fat dot becomes this cross. This fat dot becomes this cross. This fat dot becomes this cross. And when I connect those 5 crosses, that is my answer. This one here, I saw a negative. I thought flip. It's after, so it's a vertical flip. Logical, illogical business doesn't really make much sense for flips. It's a vertical flip, so that which is currently 2 above now goes 2 below. That's currently 1 above. That now goes 1 below. That's currently nothing above. It stays nothing above. And when you connect them, that will be your answer. This one, however, was a before one, so that's illogical and horizontal. I thought when I saw the multiplication by 2 stretch, it's not. It's illogical. So therefore it's a contraction and it's a horizontal contraction. So I'm going to squish everything in. The best way to do that is just to ask yourself over and over again, what are the x coordinates? Current x coordinate 1, new x coordinate half. Current x coordinate 0, half of 0 is still 0, stays there. Current x coordinate negative 1, new x coordinate negative half. When you connect them, that is your answer. So these 3 dotted graphs here, there are your final answers, and that is what the transformation of graphs topic is all about. Sometimes you get a question that stumps people up because one of the steps is skipped, but I think that makes it easier, not harder. So this question here, they've already given you the graph, therefore they don't have to tell you the algebra. But in order to ask you the question, they will introduce a little device which some people find confusing. In order to avoid telling you the algebra, they just pretend that the algebra was this thing. It doesn't really make any sense. I mean, I think some people think of that F as standing for function of x, but that's not important. Just understand that because they didn't want to tell you the algebra, probably because they didn't even know the algebra for a graph like this. This makes it easier because you do not have to do the first step. You do not have to lay down the basic graph, it's already given. What you do, however, is just go to the basic graph and lay on some key points. It's always much easier if you handle points rather than the whole graph. I've just laid down some points which seemed to me to be at the intersection of the grid lines, and now you handle this. So, in the first instance, I'm going to do this one. Okay? Now, one when I see division by 2, my gut feeling is that it is a contraction, in other words, a squish. But I'm pretty sure that if my favourite number of 10 was in there, I would divide by 2 and then handle whatever the algebra was. How do I know that? Because I've always known that you do what's in brackets first. So this is definitely a before one. Even without having to see the algebra, I know that this is a before, because you learnt in primary school that you handle what's in the brackets first. If it's like this, then that's definitely an after one, because that plus 1 is inside the brackets. So let's do the logical one first. I'll turn these back into black crosses. So I've got to lift everything up by 1, because when I see a plus 1, I think movement towards positive. This one is after, so it's logical and vertical. I think it's movement towards positives, and it is, and it's vertical movement towards positives, so that means up. So this goes there, this goes, that goes there, this goes there, that goes there, that goes there, that goes there, and that goes there. Then you have to connect them, doing your best to mimic the original shape. So that's your answer for that one. So for that one. What about my answer for this one? This one's before. Dividing by 2 would definitely happen before the main function, whatever it might be. So therefore it's illogical. I thought it was a contraction. It's not. It's a stretch, and it's a horizontal stretch. So I'm going to make some black circles out of these black dots. Current x-coordinate 0, new x-coordinate still 0 because 2 times 0 is 0. Current x-coordinate 1, new x-coordinate 2 because 1 times 2 is 2. Current x-coordinate 3, new x-coordinate 6 because 3 times that is 6. Running out of room here. Current x-coordinate negative half, new x-coordinate negative 1 because 2 times half is 1. And being a bit naughty here because I haven't finished all of them, but I'm just running out of room. This would be the answer. Okay, so in other words, we've taken this basic snake and we've stretched it out like that. The opposite of what we thought. We thought it would be a contraction because of the division by 2, but because it's inside the brackets, it's illogical and horizontal because that's what the before ones are like.